Hi students, today we're going to look into 5 tutorial questions related to chapter 6 integration. The first question, 6.1, we want to find the integral of this function 3x plus 2 power of 5. It's a bit complicated. Let us just imagine what if we're given the case of finding what is the integration of x power 5 dx. This will be easier, right? We have one tool to help us to convert the 3x plus 2 power 5 into something related to the easier version. That is using the substitution rule. This applied last week when we have this complicated case. We use the substitution rules and we can solve it very fast. Let's see step by step how to convert this complicated 3x plus 2 term functions into a more simple version. We are given the original function here. We want to find the integration of it. In order to use the substitution rules, we're going to take one symbol to represent the term. Let us assume that u equals to 3x plus 2. Then later on, we want to manipulate so that we can get the relationship du and dx. In order to find the du dx relationship, we need to differentiate du respective to the x. When we differentiate it, we're going to get du respective to x is equals to 3. And when we do some kind of adjustment, we will have dx and du related by this equation. Now, we want to fit the u into the original context. This is the original one. We have 3x plus 2. It can be replaced by u. Why? Because we had defined u same as this. Dx, we also can replace it because dx same as du divided by 3. At the right hand side, it's easier for us to do the integration. So this will be the integrals. And we need to change everything back to the x because from the beginning, we are given everything in x only. U is 3x plus 2. Then we power it with 6. This will be the final answer. We'll go to second questions, 6.2. This is similar situation. Only that now we have a defined bounded area, finding the area starting when x equals to 10 until x equals to 12. We're going to follow the same process to take the u to represent it, 9 plus x. We'll let u is 9 plus x. Then, in order to find a relationship between du and dx, we need to differentiate du respected to the x. So when we differentiate it, we only have one x here. It will have only a constant 1. Then this will be the relationship du and dx. This is the original one. Now we have u to represent 9 plus x square, maintain it, and dx is same as the du. When we have the right hand side expression, it's easier for us to integrate. Yes, it's easier. Then we're going to define it starting from x equals to 10 until x equals to 12, the lower and the upper boundaries. We take the x equals to 12, the upper, minus when x equals to 10. Finally, we will have the area bounded by the function to the x equals to 728 divided by 3. Next question, T6.3. This is a question that we want to find not a standard perspective to the x, instead to the y. Find the area under the curve. This is the equation between the point y equals to 3 and y equals to 4. Back to last week, we have the situation when we want to find the area bounded to the y-axis, not the x-axis. This will be the formula. The below formula is for the case that we want to find the bounded area by two functions. Since the second function is not exist, we can just delete the second function here. Means that this will be our formula to find the area bounded to the y-axis. The area bounded to the y-axis here. The formula for our context will be, I want to find the area, is equals to integrate the function. Our function is y power of 3 minus 9. From where to where? I want to find the area starting from y equals to 3 until y equals to 4. Follow the same process of integration. We have the power rule and also the sum rules. So this one will be the integrals of the function. Replacing y equals to the upper boundary 4. Replacing y equals to the lower boundary 3. So we put everything into the calculator or write it manually. At the end, this is the area bounded by the one function only. From where? When y equals to 3 until y equals to 4. T6.4, this is a situation where we want to find the volume. The volume from where to where? From this function to the x-axis. Means that we're going to sketch the function fx, and then we're going to identify where is the area first, bounded by the function over the ground, and then we try to imagine it rotate around the x-axis. The formula finding the volume is quite similar to the area, only that we need to have the pi and also to square the function. Okay, this is the formula for the T6.4 context, because we don't have the second function, the L, so that we can just delete this one. So we're left on finding what is the integration of the original function here. The function is same as x squared minus 4x plus 5 squared. For this problem, again, we can use the substitution rule, or if we don't want to use the substitution rule, we can expand this expression into a longer arrangement. And after that, we can do the integration. We have the power rules and also the sum rule and difference rule applied to this each of the terms. This will be the integrals of the original function. Now we want to write the x with the upper boundaries and the lower boundaries. This is the upper boundaries, x equals to 4. Later on, we want to minus with the lower boundaries, n equals to 1. When we put everything into the calculator, we're going to get the area is, sorry, not the area, the volume when this function rotates around the ground axis equals to the number here. The last question, this question is similar to our last week two curve functions, surface area bounded together. We define that area that we want to calculate is the black area here. We have the first function, y equals to x squared. Last week, we used the blue color to define it, y equals to the x squared. The second function is y equals to x power of 3. Last week, we used the red color to define it, to draw it, to sketch it. And when these two curves, they meet up together at the two coordinates, it's going to form a so-called bounded area. Last week, we used the black color to define the bounded area. A fast way to find what is the bounded area, we need to start by identifying what are the 2 points that they meet up. That will be the lower and the upper boundaries of the x. And after that, we will take the upper function, the highest line, the highest curve. When we look at our sketch, it's blue. This is the blue one, will be the upper. It's on the top. And then we're going to deduct minus it with the lower curve. The lower curve is the red color curve. The red color curve, the name is x power of 3. Then we're going to integrate. We'll come out with its integral. And then, because we want to find the area start from the first x point they meet up until the last point, the x they meet up, it happens when x equals to 1. And then x equals to 0. So we put into calculator, this will be the black color area they bounded. We're going to use the same approach to solve this week T6.5. 6.5, it has two functions. The first function is the y equals to x squared minus 5x plus 6. The second function is 2x. 2x is a straight line linear. And then we have the first function is the quadratic. If we're capable to sketch it, this will be the diagram that we can see. Because we want to find what would be the area bounded by these two, these two functions here. After the sketching, it is the black color area. The top we need to include, and also there is a small tiny area of the curve here that located beneath. But no problem, when we use the first function, that is the upper function, minus the lower function, it's going to auto-calculate all the areas bounded by these two functions. We take the upper functions, that is the y equals to 2x, minus to the lower little bit function here. So we can come out with the answer without need to consider this area, and that area, this small area, and this upper area. Okay. First step is to find what are the 2 points that they meet up together. The coordinate of the y from the first function is equals to the y of the second function. Means that we can say that x squared minus 5x, because it's the y, plus 6 will equals to the another y, 2x. So from this process, we can find what are the 2 x's that they meet up, and then we can replace x into y equals to 2x to find what is the y. Okay, finding the 2 points, that will be the lower and the upper boundaries of the x. You're going to get one of the x is 1 and another x is 6 later on. Okay, now we're going to find the integration in general to represent the black color area. The integration of the black color area is equals to the first upper function, straight line, y equals to 2x, or 2x, minus the lower function, x squared minus 5x plus 6. Now we're going to merge them together, and then we will integrate it. We'll cut out one integral here. Then we're going to define it starting from from x equals to 1 until x equals to 6. What will be the area? Finally, we will come out with the area is 125 divided by 6. For this problem, try it yourself. After you try it on the paper, you solve it. No need to create a video. You just submit a photo. You snap a photo, submit it. Snap a photo and submit it at the Google form here. And then you can check your submission on the second link here. And your submission will be your attendance for this week, this session. You can check your attendance on 18 June, Thursday, 10 p.m. Okay, take care all. Bye.